Hello everyone! This is our last video for Math 7 for the school year 2020-2021. We are going to talk about our last practice exercise for our last lesson on our last unit for the last grading. This is practice exercise B, which is still on the terms associated with a circle. We will not be computing anything for yet in for this grade level, for we are just going to polish our understanding on the terms that could actually be associated with a circle, and that we will be prepared later on to dig deeper on circles as we proceed to higher level mathematics. In the previous video, we're able to talk about the points, line segments, and lines associated with a circle. Now we are going to talk about the angles and the arcs. Okay. If we talk about angles, yes, circles do not have vertices. I mean that have sides, that have vertices, but and then we cannot come up with interior angles. But we could actually use the line segments associated with a circle and come up with angles. And we have two types of angles in a circle. We have the central angle and we have the inscribed angles. If we talk about central angles for number one, from the name itself, central, it is actually an angle wherein its vertex is the center of the circle. So the center of the circle here is at A. That's why it's also known as circle A. So the angles formed with this as the vertex are considered to be our central angles. And these are actually the angles here. This angle here and the other one on the other side. Okay. And you can even say this angle here as it is also an example of an angle, specifically a straight angle. Okay. So how do we actually name these angles here? Definitely, we use the vertices. So for number one, we have here angle. Let's use this first. Angle BAC. Please don't forget how to name angles. Okay. We used three letters here because the vertex A is also the vertex of the other angles, as it is the center of the circle, and we place that vertex in the middle. The next angle, in central angle formed here, is angle BAD, or sorry, that's D, or DAB, right? So you can just simply interchange them as long as A, the vertex, is on the center. And the last angle is this angle here, which is angle DAC or CAD. But this name could actually also be true with this side here. Nevertheless, it's already with this name here, so let's just simply stick with that. So these are the central angles. Again, central angles are angles where the vertex is at the center of the circle. Okay. If that would be the case, the sides of central angles are radius. Radius. We have here radius as well. Radius and radius. For number two, we are going to talk about inscribed angles. Now, if we talk about inscribed, uh, figures, they are found on the circle. Okay, if we have inscribed square, so we have the circle, we have here the inscribed square. Inscribed triangle, we have the inscribed triangle here. Okay, but if we talk about circumscribed square, the circle is found on the center. Circumscribed triangle, the circle is found on a triangle. I'm just including that one for emphasis, but don't be concerned, it's not part of our concern as of this level. Well, anyway, let me erase that. No, there will be no confusion. If we talk about inscribed angles, its vertex is a point on the circle and its sides are chords. And the chord may be a diameter because, again, a diameter is the longest chord. I'm talking about this angle here. Okay? This angle here, its vertex is as point C, a point on the circle, and its sides are chord and chord. So for number two, our answer here is angle B C D, because that is the angle with the uh, vertex is on the circle as point C, and we have there the chords as its sides in terms of chord BC or CB and DC or CD. That is only our that is our inscribed angle. How about this angle here? Its vertex is a point on the circle. Its side is a chord. However, the other side is not a chord, it's just a radius. So is it an inscribed angle? The answer is no. Per definition, this should be a chord so that it could be considered as an inscribed angle. But since it's just a radius, the answer is no. How about this angle here? This angle here at this vertex, uh, a point on a circle, vertex C. One of its sides is a chord, but the other side is not a chord as it is found on the outside. So that would mean we only have one inscribed angle here, angle BCD. Okay. Now let's proceed to the arcs. Aside from angles, take note that angles are in the degree measurement. We also have arcs, which is also in degree measurement. And there is a very important relationship between central inscribed angles and their intercepted arcs. But again, it's not the concern of this level. Let us try to talk about first on semicircles. Semicircles means half of a circle. So that is actually an arc, okay? Because it is a measurement that is actually 180 degrees and it is the half of the 360 degrees, which is the complete circle. In this case, we have this semicircle here, which is DC. And the proper notation for semicircle is this curve here, or actually that, let me make it better, curve. Yeah. This means it's the curve DC, or I mean arc DC or arc CD, which is considered to be a semicircle. The other arc is on the other side, which is also DC, as this is also the other half of the circle. But to differentiate the two, we'll be using the other point on the circle, which is point B. That would mean this is D, B, C, or CBD, and we have this arc. I'm just renaming them differently so that it could actually, I am referring them in different things. So if I will say arc DC, I'm referring to this side. And if I'm referring to arc DBC, I'm referring to that side with point B on a point on the circle. Okay, that is actually, these are actually the two semicircles here. Why? Because we only have one diameter, and that diameter divides the circle into two equal parts. So if we have this diameter, just assumption, if we have this diameter, okay, so we have two diameters, that would mean we have additional of two semicircles coming summing up to four semicircles because one diameter comes up with two semicircles. Okay, let's proceed to number four. Number four is a minor arc. A minor arc is an arc that is less than a semicircle. Okay, let's focus on this figure here because it's too uh, confusing there now. As of this figure, we have this minor arc here from B to C. Okay, this is less than semicircle. So that is our first minor arc, B, C, or CB. And the other minor arc is this. Okay, we have here BD or DB. Any of them could do. But if we are going to say arc BDC, it's more than a semicircle. It's not anymore a minor arc, but it's what number five is concerned on, the major arc. The major arc is more than a semicircle, but not enough to become a circle itself. Do not say B, C, D, and it will become the circle itself. That's a no-no. So minor arc is actually an arc which is more than a semicircle, but less than the circle itself. So if it's more than a semicircle, it includes a semicircle. So if we have a semicircle D, C, we could actually go towards B. And that is actually the major arc here. So major arc D, sorry for that, B, C, B, or BCD. That's the major arc. Okay. And the other one is by moving on the other way around. Okay. So if I will start here at C, and then we have here the semicircle D, and we add here arc BD, our DB, sorry. So we have here C, DB, or arc B, D, C. So these are the two major arcs in this given figure. What if I will start with this and then I will focus on this semicircle at the top? So you have D, B, C. But if I will continue, I will not have any point on the circle here. I'm just going to complete my revolution or rotate a revolution rather. So that would mean this is not possible here. So we start with the semicircle and then the other way around as well. So again, as I mentioned earlier, there are special connections between central angles and inscribed angles with their arcs, intercepted arcs. Intercepted arcs meaning the arc they are facing to. So if this is our central angle here, the arc it is facing to is the arc BC. There is a special relationship to that. And we have here the inscribed angle, this area here. The arc it is facing to is this arc here. They also have special relationship, but that's not our concern for this grade level. So this is the results for the last practice exercise. So again, I have been mentioned last practice exercise. Hopefully you have been learning and you have been enjoying these videos. So please use this video as part of your review. Hopefully you have enjoyed your journey in Math 7 and we'll see you again soon in your next grade levels. Thank you very much. Goodbye everyone. See ya.